A blinding explosion rips through the sky. Starship Flight 8, SpaceX's most ambitious spacecraft, is gone in seconds. What went wrong? Was it a simple malfunction or a major setback for the future of space exploration? Some see it as an expected failure. Others call it a disaster. But one question remains: can SpaceX recover? Or is this a warning sign for future missions? The answer is more complex than it seems. And it all starts with understanding what really happened. Starship Flight 8 was supposed to be another step toward humanity's future on Mars. Instead, it ended in flames. Everything seemed to be going well. The launch was successful, the separation of stages was flawless, and for a moment, it looked like SpaceX had achieved another milestone. But just minutes into the flight, something went terribly wrong. Fire erupted inside the spacecraft. One of the engines failed, and then an uncontrollable spin. Moments later, the inevitable happened: a violent explosion, leaving nothing but debris falling from the sky. This failure isn't just about one test flight. It has massive implications. NASA has placed its trust in Starship to land astronauts on the Moon for the Artemis program. Every setback raises concerns about delays, budgets, and whether SpaceX can truly deliver on its promises. But Elon Musk isn't backing down. Almost immediately, he promised another test flight in just a few weeks. Is this confidence or recklessness? And more importantly, will the next Starship meet the same fate? Before we answer that, we need to look at the facts. What really led to this catastrophic failure? Long before the explosion, signs of trouble were already emerging. The launch had been delayed multiple times due to technical issues. Engineers struggled with problems in the fueling system, unexpected pressure fluctuations, and last-minute adjustments to the spacecraft's structural integrity. Every delay meant more testing, more fine-tuning, yet, when the countdown finally reached zero, the world watched as Starship Flight 8 roared into the sky. At first, everything seemed flawless. The massive engines ignited, generating an incredible force that lifted the rocket with precision. The first stage performed as expected, and the booster successfully separated from the upper stage. This was a critical moment, one that had caused problems in previous flights. But this time, it worked. Starship was now flying on its own, reaching higher altitudes than ever before. Then, the problems began. 7 minutes into the flight, onboard cameras captured something alarming: flames appearing near the engine bay. This wasn't just minor heating. Something was burning, and it was spreading fast. Seconds later, one of the Raptor engines failed. The loss of thrust sent the spacecraft into an uncontrolled spin. From the ground, engineers scrambled to analyze the data. Could the onboard systems correct the trajectory? Could the remaining engines compensate for the failure? The answer came in a matter of moments. The spacecraft's rotation became more violent, pushing the structural limits of the vehicle. Then, in a flash of light, the inevitable happened. Starship exploded. The mission was over. But what exactly caused the fire? Was it a fuel leak? A flaw in the engine's thermal insulation? Or was it something even more serious? An issue that could impact all future Starship flights? The investigation began immediately. SpaceX engineers examined the wreckage, reviewing every piece of data to understand what went wrong. Meanwhile, the public and space community were left with one big question: how will this impact the future of Starship and the broader goals of space exploration? And more importantly, how did NASA, other space agencies, and the scientific community react to this failure? As the fiery debris of Starship Flight 8 fell back to Earth, the reaction was immediate. Across social media, space enthusiasts expressed their disappointment. Some had stayed up all night to watch the launch, expecting to witness history. only to see another explosion. Memes, debates, and heated discussions flooded the internet. Was this just another step in the learning process? Or was SpaceX moving too fast and risking too much? For NASA, the situation was more than just a viral moment. Starship is a crucial part of the Artemis program, designed to land astronauts on the moon. Every failure raises concerns about potential delays. If SpaceX can't make Starship reliable, NASA's timeline for returning humans to the lunar surface could be in jeopardy. Could this setback force NASA to consider alternative solutions? Meanwhile, experts in the space industry had mixed reactions. Some saw the failure as an expected part of innovation. This is how progress happens, they argued. Others, however, were less forgiving. Some scientists and engineers questioned whether SpaceX's rapid testing philosophy, launch, fail, learn, repeat, was sustainable, especially for missions that will one day carry human crews. The explosion had sent shockwaves across the aerospace world. But was it just a temporary setback, or a warning sign for the future? The explosion of Starship Flight 8 sparked a fierce debate. Was this just another necessary failure? Or did it reveal deeper issues with SpaceX's approach? Supporters of SpaceX pointed to the company's long history of overcoming setbacks. The Falcon 9, now one of the most reliable rockets in history, once had multiple failures. The same pattern applied to the early days of Falcon Heavy. To them, this was simply how innovation worked: fail fast, learn faster, and improve. In their eyes, this failure was just another stepping stone toward success. Elon Musk himself echoed this mindset. He reassured the public that each test provided crucial data, making Starship stronger with every launch. His confidence remained unshaken. Another flight would happen soon, with improvements already in place. If history was any guide, SpaceX would find a solution quickly. But not everyone was convinced. Critics raised concerns about the repetitive nature of the failures. Some pointed out that Starship had suffered similar issues in previous tests: engine failures, instability, and uncontrolled spins. Was the company truly learning, or just rushing ahead without addressing core problems? A more alarming question loomed. What if these issues occurred on a crewed mission? The current failures were costly, but ultimately harmless. However, once astronauts were on board, the stakes would be far higher. Would SpaceX's trial and error approach still be acceptable then? While the debate raged on, one thing was certain: the pressure was mounting. The next Starship flight had to show real progress, or doubts about its future would only grow stronger. Despite the explosion, SpaceX wasted no time preparing for the next launch. Engineers analyzed every piece of data, focusing on two major issues: engine reliability and vehicle stability. One proposed solution was the Raptor 3 engine upgrade. This next-generation engine promised increased efficiency, better thermal management, and improved durability. If successful, it could eliminate the failures seen in Flight 8. Another critical improvement involved thermal shielding and onboard fire suppression. The fire that led to Starship's spin and eventual explosion was a major concern. SpaceX planned to reinforce insulation around key components and introduce automated systems to detect and extinguish onboard fires before they spiraled out of control. Ground tests were also set to become more rigorous. Instead of relying solely on flight data, SpaceX aimed to stress test Starship's structure and propulsion systems more aggressively before the next launch. But would this be enough? The company announced that another test flight was only weeks away. Optimists believed this was a sign of confidence. Skeptics, however, feared SpaceX was once again rushing ahead without fully solving the problems. The next flight would be decisive. Would it prove SpaceX's approach right? Or would it end in another fiery disaster? Starship Flight 8 wasn't the first failure. and it likely won't be the last. But is SpaceX learning fast enough? Flight 7 had its flaws. Flight 8 ended in an explosion. Will Flight 9 finally succeed? Or are we in for another disaster? Let me know what you think in the comments. And don't forget to subscribe so you don't miss the next launch.